The energy of a photon is directly proportional to its frequency. So energy is directly proportional to its frequency and it's inversely proportional to its wavelength. All right, so as to fill this table out, notice this is in centimeters, so let's turn that into meters. We can do that by dividing by 100, because when you have a number here in centimeters, you can turn that into meters by using this conversion factor. Divide by 100. So when you divide by 100, you just lower the exponent by 2. So this is -5, this is -6, -6, -6, 10 to the -6, and 10 to the -7. See if there's any more. That's it. All right, so let's just get that out of the way. And there's a couple equations we can use. We can use that energy is equal to Planck's constant times the speed of light over the wavelength. We give you that. Probably the easier or the faster way to do this is going to be, is using the speed of light is equal to the wavelength times the frequency, because you'll just have to, there'll be less key entries. I'm going to use this here, and actually before we do that, to get frequency, let's rearrange that. To solve for frequency, we'll divide through by lambda, and we'll have frequency is equal to the speed of light over the wavelength. So this is the one I'm going to use. Just going to be fewer keystrokes. All right, got my calculator out here. So speed of light is 2.998 times 10 to the 8 divided by the wavelength, 5.77 times 10 to the -5. Got to use the meters one here if I'm going to use. I guess I could have converted speed of light into centimeters per second. But I want to use meters. All right, so there we go. That's the frequency. Let's get this 3 significant figures, because all the numbers they give us is 3 significant figures. So 5.20, 5.20. Let me pick a different color. 5.20 times 10 to the 12. All right, next number. I'm just going to copy that equation and just change the wavelength. So the second wavelength given is 6.82 times 10 to the -6 meters. So that's going to be 3 sig fig is 4.40 times 10 to the 13. Copy. Replace the wavelength. 3.16. The rest are times, that one's also times 10 to the 6, so we're good. Or times 10 to the -6. So that's 9.49. 9.49. Times 10 to the 13. Next one, copy. Just change the wavelength to 1.76. It's already at times 10 to the -6, so it's 1.70 times 10 to the 14. Copy, change the wavelength, 1.36. And that's 2.20 times 10 to the 14 hertz, or per second. One more to go. Copy. This time I have to punch in the whole wavelength because the exponent is different here. 6.38 times 10 to the -7. 6.70 times 10 to the 14 hertz. So there we go. We completed the table. We're done with part A. Part B, plot the energy versus frequency. Okay, so I just need the first two columns. It says energy and frequency. I don't need the third one. Copy that. There it is. Get some axes here. There's my Y. There's my X. Oh boy, how am I going to scale the Y? There's my smallest number. And there's my biggest number. Oh, goes from small to big, looks like. I'm just going to use my calculator. Alright, let me, alright, back with my calculator. This is just, I mean, we could do that. It would just, I don't feel like explaining how to scale this. And so let's put this stuff into, just clear my calculator. Put this stuff into a list here. So I want to stat, edit. Let's put the X values, the frequency in the L1 column. 5.2 times 10 to the 12, enter 4.4 times 10 to the 13, enter 9.49 times 10 to the 13, enter, let's just do the last one here, 6.7 times 10 to the 14. Don't feel like doing all that. We only need to do two of these, right? Get 2 points on the line. All right, let's go with the, now we're going to match these up. So 3.45 times 10 to the negative 21. Wait, hold on. Did I do that right? 3.45 times 10 to the negative 21. 2.92 times 10 to the negative 20, and 6.29 times 10 to the negative 20. Then we went all the way down to the last point, 3.11 times 10 to the negative 19. If all these points are on the same line, then we could have just picked two. Alright, so let's, forgot how to do this, can't graph that. How do we, yeah, there we go. Second, stat plot, because our list is in the stat button there. So let's press enter. Let's turn that thing on. Let's go down, hit that line. Looks good. And then graph. No. All right. How do we graph this? Oh, we gotta zoom maybe into. Oh, what? Get out of there. Quit. Let's zoom in on our list here. Zoom stat. Ah, there we go. Ah, that doesn't even look like something. Did we do something wrong? Doesn't look like a line. Ah, let's check our list. Alright, that one looks good. I'm reading down there. 3.45, 21, 2.92, 6.29. Oh, I hit the wrong number. Okay, that's the problem. Alright, so that one's supposed to be 1.13 times 10 to the negative 19. Oh, wait a minute. I skipped that. All right, I want to put all of them in. All right, so there's that. I'm going down here to the 1.46. I'm putting them all in. Times 10 to the negative 19. and then 3.11 times 10 to the negative 19. Alright, there's all my y's. Let's check my x's. 5.2 times 10 to the 12. Alright, they changed them all into alright, that one's good, that one's good. Okay, I'm going to put them all in here. 1.7 times 10 to the 14. 2.2 times 10 to the 14. And the last one is 6.7 times 10 to the 14. Alright, see if that works better. Hit that stat plot. Everything looks good. Graph. And then let's zoom into the stat. Why is this? What is this last line here? 1, 2, 3, 4, 5, 6. Why is it so far out? Let's do that last one again. Good. All right. 2.998 times 10 to the 8. That's our speed of light divided by the wavelength. What was the wavelength? 6.38 times 10 to the negative 7. Oh, I messed that up. Okay, well that kind of explains it. So this here should be 4.70, not 6.70. Alright, this is, sorry, not doing this video again. There it is, 4.70. Now you gotta go back here. Okay, you should always like check your work, because by checking your work, it's like you saw that line wasn't straight. All right, let me go back into this stat list. Go into the what is that, x? That should be 4.7 times 10 to the 14. All right, just let's. There's a straight line. There we go. That's good. Now let's get the. Well, there it is. We're done with B. Plot the graph. Determine the slope. We're just going to let the calculator do that as well. So go to Stat, Calculate, Linear Regression. There's X on list 2. Right? We put the X on the. I forget where we put the X. Let's go back. X is on L1. Okay, so that's good. All right, go back to Stat, Calculate, Linear Regression. X is in. Yep, that looks good. That looks good. That looks good. Let's calculate. So mx A is the slope. So the slope is 6.62. Why is it? It's a little off. All right, but it should be Planck's constant. 6.62 times 10 to the negative 34. Right, and the unit on the y-axis is joules, and the unit on the x-axis is seconds. Or it's rather per seconds, but all right, let me go back here, slow down. No, where's our graph? So on our graph here that we never finished here, this one is joules because that's energy of the photon, and over here is per second. So joules per second is joule seconds. All right, so the slope is 6.6 because you're going to bring this up here. 6.62 times 10 to the negative 34 joules seconds. And you know what that is. That's Planck's constant. All right, you knew where we're going to get that, right? So that's the answer to part D, Planck's constant. And the slope is the number we circled.